Okay, so moving on to Bronsted-Lowry acids and bases. So according to the Bronsted-Lowry theory, an acid is a substance that's going to donate those hydrogens, where a base is a substance that accepts hydrogen. And if you remember what our pH scale is, it actually kind of makes sense because remember how acidic we are is based on how many free hydrogens we have floating around. So if we have more H pluses, that's going to be more acidic. Where if we have less H pluses, then that's going to be more basic or alkaline. So it would make sense that an acid is going to be a substance that's going to donate those H pluses because then we would have more H pluses swimming around in the solution, therefore making it more acidic. So you can see a picture here with water, the hydrogen ion, and then when it combines together, that's the hydronium ion, okay? So this one's going to be accepting that hydrogen, so this would be a base. Where this one, okay, is going to be having an acid plus a base together, and it's going to make an acidotic solution. Okay, so according to the Bronsted-Lowry law, NH3 is a Bronsted-Lowry base, or Lowry base. In the reaction of ammonia, which is NH3, and water, NH3 accepts as the base that accepts that hydrogen, or water, or H2O, accepts as the acid that donates the hydrogen. So again, looking at that formula, you can have the ammonia, which is the base, or the hydrogen acceptor. Then you're going to have the donor, which is the acid, and then when they come together after the reaction, we make the ammonium ion, and then we have the hydroxide ion left over. So the different characteristics of acids and bases is, again, here are your characteristics, acid, bases. So remember pretty much whether they donate or accept the hydrogens, if what they taste like, not that you're going to be eating these guys, but, phenylephthalene, how they change the color, etc. So this is a great little summary. So for our study check here, in each of the following equations, let's identify the Bronsted-Lowry acid and base in these reactions. So pause me and come back. So HNO3 is going to be your acid, and H2O is going to be your base because of how we donate and accept. Okay, and then for this one, HF is your acid, and H2O or water is going to be your base. Okay, so it's pretty straightforward. So identify each of the following as a characteristic of either an acid or a base. Okay, use that table, pause, and come back. So what did we get? So an acid has a sour taste. A base produces an OH or hydroxide in an aqueous solution. B, a base has a chalky taste. Both an acid and a base is an electrolyte. And an acid produces H pluses in aqueous solutions. Right, great job.